please say whether my slides are visible or not.
Yes, sir.
Slide visible? Okay, okay. So, good morning to one and all. We have almost came to an end part of this particular module. If you remember in the last class, I have told you that we are left with one more topic of this module, and that topic is nothing but wedge friction. That topic is nothing but wedge friction. Now, what is this wedge friction, or what is a wedge, what is the function of wedge, and how this wedge friction takes place? We will be going to understand in today's class. So a wedge, it is nothing but basically it is a piece of metal or wood in the shape of prism, whose section is usually either triangle or trapezoidal, and it is used for lifting the load. If you see this diagram, this trapezium portion, that means this portion, if you consider this portion, this is a wedge, this is a wedge, and this is a load which you want to lift. How you can lift? You have to take the help of wedge. How you can lift the load by the help of wedge? If on this wedge, if you apply a force P in negative x direction, what will happen? Wedge will move in this direction. Since the load is in contact with the wedge, as a result of which the load will move upward. Is it clear? Is it clear?
Yes, sir.
Again, I am repeating, what is a wedge? Wedge is an object with the help of which you can raise any kind of load. You can raise any kind of load. Now, this shape of this wedge can be either a trapezium in shape or it can be triangular in shape. If the wedge is in triangular in shape, then I can say that this is the cross section of the wedge. Now, over this wedge, if you keep a block, if you keep a block like this, and you are interested in raising up this block, how you can raise it up? If you apply a force in horizontal direction to this wedge in negative x direction, then what will happen? The wedge will move in this direction. Okay, and since the block which is in contact with the wedge, since as a result of which if the wedge is moving in this particular direction, the block will move along this direction, and if you see, the overall this block will raise up. So this is the purpose of wedge, and the friction introduced between the contacting surface of the load and this wedge is known as your wedge friction. You can see that the load surface is in contact with this wedge surface over here. So your load will only move up or will raise up by the help of wedge if there exists a friction between the two contacting surfaces, and that type of friction is known as wedge friction. Is it clear?
Yes, sir.
Okay, so now read the second PowerPoint. While lifting the load, wedge is placed below the load and a horizontal force P is applied. The wedge moves towards left and the load moves upward. You can see that if you want to lift this load, you need to place the wedge below the load, and on this wedge you have to apply some horizontal force. Fine, in this particular direction, then the wedge will move in this direction and load will move upwards. Okay, so if we do the analysis part of this wedge friction, so let us draw the free body diagram of this particular problem. Let us draw the free body diagram of this particular problem. Now by looking at this diagram, I can clearly say that I am having two objects. One is your wedge and the second one is your load. So individually we will draw the free body diagram of both the wedge and the load separately, and then we will use the equations of equilibrium to find the values of unknown parameter from these free body diagram. So let us see what all forces act on wedge and on this load during the entire motion. Okay, so you can see the leftmost figure is nothing but the FBD of your wedge, and the rightmost figure is nothing but the FBD of your load. So if I assume that the wedge is in contact with the horizontal surface CD, assume that that contacting surface is nothing but point number 1. Contacting surface between load and wedge is nothing but point number 2. And contacting surface between load and this vertical wall, assume that FG is a vertical wall, that contacting surface point is nothing but point 3. So if I draw the FBD of wedge, so the weight of the wedge will act vertically downward from the center of gravity. Okay, now this wedge is in contact with the horizontal surface CD, that is nothing but the first surface. So this first surface will give a reaction to the wedge vertically upward. This is that reaction R1 in this direction. And since the wedge is moving in this direction, so a frictional force exists between the wedge and this horizontal contacting surface, and that frictional force will be in the opposite direction to the direction of motion of the wedge. So since the wedge is moving in this direction, so frictional force will be in this direction, that is mu1 into R1. Mu1 is coefficient of friction between the horizontal surface 1 and the wedge. Okay. Next, you can see that on this wedge, an external load P is applied in negative x direction. Apply external load P in negative x direction along BD. You can also see that this wedge is in contact with the load. So load will give a reaction to the wedge in this direction, R2. Why R2? Because I have assumed this is surface number 2. So R2. Now since the wedge is moving in this direction, that means if you see the contacting surfaces, this is my contacting surfaces, at this contacting surfaces a frictional force will exist. Fine, and that frictional force will be in the opposite direction to the direction of motion of the wedge. Since the wedge is moving along this direction, so if I look at this contacting surfaces, the wedge is moving like this. If the wedge is moving like this, frictional force will be acting in this direction. So this is that frictional force mu2 into R2, where what is mu2? Mu2 is coefficient of friction for the surface number 2. So this is the free body diagram of this wedge. Any doubt in this free body diagram of the wedge?
No, sir, no doubt.
Okay. In the same manner, I have to analyze the load part also. So let us draw the free body diagram of the load. So this is my load. This is my load. This is your load. Now let us assume that this load, since this load is in contact with this vertical surface, which is nothing but my surface number 3, so this third surface will give a reaction in this direction, and that reaction will be R3. See, R3 in this direction. And since the load is moving upward, so a frictional force will exist between this vertical surface and this load, and that frictional force will be in the opposite direction to the direction of motion. That is nothing but mu3 into R3, where mu3 is coefficient of friction between the load and this vertical surface. Now this load is in contact with wedge along GH, that is surface number 2. So wedge will give reaction to this load. So this is that reaction R2. See, this is that reaction R2. Now since the load is moving up, but if you see the contacting surface between the load and the wedge, which is nothing but GH, there exists a frictional force, and direction of that frictional force will be opposite to the direction of motion of the body, and that body is nothing but load. If the load is moving up, then if you observe this contacting surfaces along this GH surface, load is moving in this direction. If this is the direction of load, then the frictional force will be acting on this contacting surface in this direction, which is nothing but mu2 R2. So this is the FBD of this load. Now you use the different equations of equilibrium, that is Fx0, Fy0, moment 0, and we will try to find out the unknown parameter given in the problem. So this is all about wedge friction. Any doubt in wedge friction, or any doubt regarding the FBD part of the load and the wedge?
No, sir, no doubt.
Okay, let us solve some problems, then it will be clear to us that how this wedge friction works. Let us solve this problem. The problem is block A weighing 1000 Newton is to be raised by means of a 15-degree wedge B weighing 500 Newton. That means from the given diagram it is very much clear that block A is nothing but my load, which I need to raise up by the help of a wedge, which is nothing but my second block, that is block B. And weight of both the blocks are given to you, that is 1000 Newton for block A and 500 Newton for block B. Definitely those weight will act from the center of gravity of the two blocks. Okay, somebody is joining, please wait. Okay, so assuming coefficient of friction between all contacting surfaces to be 0.2, so you can see in the diagram that this is one contacting surface, this is one contacting surface, this is the second contacting surface, and this is the third contacting surface. So for all these contacting surfaces, coefficient of friction value is common, and that value given is mu equal to 0.2. What we need to determine? We need to determine that what minimum horizontal force P should be applied to raise the block. That means what is the minimum value of force P which I should apply on this wedge B so that my block A or load A will move upward. This is the problem given to you, and this angle of wedge is also given to you, and that angle is how much? 15-degree. Wedge angle is given to you, that is 15-degree. So ultimately we need to find out the minimum value of force P required to be given to this wedge in order to raise this block A upward. So this is the problem. Did you understood the problem? Any doubt?
Yes, sir.
Any doubt in understanding part of the
No,
problem?
no, sir, no.
Okay. So then let us solve this problem. So the very first step is I have to individually draw the free body diagram of wedge separately and this block separately. So this left hand diagram is the FBD of your wedge, that is block B, and this right side diagram is the FBD of block A, which we need to trace. So let us see how this FBD.
Sir, you're audible, sir.
Sorry, am I audible?
Yes, sir, I'm audible.
Okay, what I was telling was that we need to draw the free body diagram of the wedge B and the block A separately, and then we have to use the equations of equilibrium. We have to eliminate something, and by this process ultimately we will get the value of force P. So first let us draw the FBD of wedge B. So this is your wedge. This is your wedge. Okay. This is my wedge. Now assume that the wedge is in contact with this horizontal surface. Let us assume that this surface is nothing but surface number 3, and contacting surfaces of the block and the wedge is nothing but surface number 2, and the contacting surface of this block and this vertical wall is nothing but surface number 1. So I can see very clearly that the weight of the wedge, that is 500 Newton, it will act vertically downward from the center of gravity. So your 500 Newton weight. Then you can see that this horizontal surface is in contact with this wedge. So this horizontal surface will give a reaction to this wedge in this direction, which is nothing but your N3, normal reaction force, that is N3. Now since this movement of this wedge is in this direction, so frictional force which is present between the contacting surface of this wedge and the horizontal surface, it will be in this direction, that is mu times of N3. Mu is nothing but 0.2, so zero point 0.2 times of N3. On this wedge, horizontal force P is applied along negative x direction. This is that horizontal force P. Now this wedge B is in contact with the block A. So block A will give a reaction to this wedge B in this direction. That is nothing but your R2 or N2. This is nothing but your N2. Okay. And since the wedge is moving along negative x direction, if I see the contacting surfaces, this part of the wedge, this taper, this part of the wedge, it is moving along this direction. That means it is moving this way. Then the frictional force will act in this direction, which is your mu times of N2, that is 0.2 times of N2. So this is the final FBD of this wedge. Any doubts so far?
No, sir. Sir, no.
Okay. Similarly, I will draw the FBD of the block A also. Let us draw. This is my block A. This is your block A. Weight of the block acting vertically downwards from the center of gravity, that is 1000 Newton. Block A is in contact with this first surface. So this first horizontal surface will give a normal reaction to this block in this direction, which is nothing but N1. This is your N1. Now since this block A is raising upward, so at this contacting surfaces a frictional force will act opposite to the direction of motion, that is mu times of N1, 0.2 times of N1. Now this block A is in contact with this wedge B, so wedge B will give a normal reaction to this block A in this direction, which is nothing but your N2. This is your N2, and since this block A is moving upward, if you see the contacting surfaces of block A and block B, this is the contacting surface. At this surface, motion of the block A will be in this direction. So frictional force will act in this direction, which is zero point 0.2 times of N2. So this is the final FBD of the block. Any doubt in the FBD part of wedge and the block?
No, sir, not audible.
Okay. I can see that one electrical people have also joined. So can you respond whether it is clear or not so far?
Yes, sir.
Okay. So let us write down the equations of equilibrium for wedge separately. That means for wedge, let us write down Fx equal to 0 and Fy equal to 0. And for the block separately, we will write down Fx equal to 0 and Fy equal to 0. And we will see that from these equations whether we can find out the value of force P or not. Okay. So let us write down the equations of equilibrium for this block A. Okay. So before writing down the equations of equilibrium, I have to resolve some forces. Which force I have to resolve? You can see this is N2 is acting in this direction. This is your N2. This is your N2. Okay. And this angle is 15 degree. This angle, if this angle is 15 degree, definitely this angle will also be 15 degree. If this is 15 degree, I can make this triangle. I can make this triangle. In this triangle, okay, just wait. Somebody is joining. Yes, I was telling about this triangle. So if I make this a triangle, this angle is 15 degree, this angle is 90 degree, then by triangle property I know that this angle will be how much? 75 degree. This angle will be 75 degree, that is 180 minus 15 plus 90 degree. So that means I can see that N2 force is acting at this particular second surface. This is the force N2. Fine, and it is acting at an angle of 75 degree. That means this angle is given as 75 degree. Okay, so I can resolve it. This is the tail end of this N2 vector and this is the head end. That means I have to go from this to this end. How I will go? Let us move along this side and then let us move along this side. Then this particular component will be your N2 cos 75 and this particular component will be your N2 sin 75. Is it clear? Is it clear?
Yes, sir.
This is how I
Yes,
have
sir.
resolved this N2 force. Okay. Any doubt? Electrical people, please respond. Any doubt is there?
No, sir.
Okay. Now you can see on that same surface, this frictional force is acting zero point 0.2 times of N2, which is acting in this direction. Again, I have to resolve this force. I can see that this angle is 15 degree. Definitely this angle is also 15 degree. So that means this is your zero point 0.2 times of N2. This is your zero point 0.2 times of N2. Okay. And this angle is given to you. This angle is given to you 15 degree. This is the tail end. This is the head end. I have to move like this. vertically like this and horizontally like this. If this is 15 degree, then this component will be zero point 0.2 into cos 15 and this component will be 0.2 into sin 15. Is it clear? Is it clear?
Yes, sir.
Yes, sir.
Okay, so now we have resolved the forces. We have resolved this N2 force and this point N2 force. Why? Because this N2 and point N2 forces are not directly acting along X and along Y axis. It is acting at some angle along this second surface. So I have to resolve these two forces. So now we have resolved. Now we can write down the equations of equilibrium. So let us write down summation fx equal to 0 and summation fy equal to 0 for this block number A. So let us write down. So first I have written summation fx equal to 0. That means I can write plus n1. See, I can write plus n1 minus n2 cos 75 minus zero point 0.2 into cos 15 equal to 0. No other force is present. See, n1 minus zero point 0.2 into cos 15 minus n2 cos 75 equal to 0. There is no other force along x axis. So n1 minus zero point 0.2 into cos 15 is 0.193 times of n2 minus cos 75 is 0.258 into n2 equal to 0. So with this you will get one relation in terms of n1 and n2, which is nothing but equation number 1. That is n1 is equal to 0.451 times of n2. Is it clear so far till equation number 1? Any
Yes,
doubt?
sir.
कोई डाउट है किसी को?
No, sir. No, doubt.
ओके, इलेक्ट्रिकल पीपल प्लीज रिस्पॉन्ड. कोई डाउट है?
Yes, sir.
ओके. Next, let us write summation fy equal to 0. If I write summation of all the force along y direction equal to 0, I can write minus 1000 minus zero point 0.2 times of n1 plus n2 sin 75 minus zero point 0.2 times of n2 sin 15. See, n2 sin 75 minus zero point 0.2 into sin 15 minus zero point 0.2 n1 minus 1000 is equal to 0. So if you solve this particular expression, yes, now if you solve it, see, sin 75 is 0.965 times of n2 minus zero point 0.2 into sin 15 is 0.051 times of n2 minus zero point 0.2 n1 minus 1000 equal to 0. Now from equation number 1, you know that n1 is 0.451 times of n2. So in this equation, in place of n1, replace that value by 0.451 times of n2. Once you replace it, each and every term will be in terms of n2. You can easily get the value of n2, and that n2 is coming out to be 1213.88 Newton, and just substitute the value of n2 in first equation. You will get the value of n1, that is 547.45 Newton. Is it clear? Any doubt?
Yes, sir. No, sir. No, doubt.
Okay. So from the free body diagram of the first block, that is block A, what I got? I got the values of N1 and N2. But I need to find out the value of P force. So for that I have to write down the equations of equilibrium for this wedge part also, because on this wedge part this P force is acting. So let us write down the equations of equilibrium for this wedge part. But before writing down the equations of equilibrium, let us resolve some forces which are not directly acting along x and y axis. Okay, So we can see that this which force, this point 2 N2 force, it is acting in this direction. And if this angle, that means this is your point 2 N2, okay, and this angle is given to you, that is 15 degree. That means this angle is 15 degree, and this is your 0.2 times of N2. So I can resolve like this. This value will be 0.2 into cos 15. This is 0.2 into sin 15. Fine. And this is your N2. Now this is your N2 for this wedge. For the previous case, that is for block A, this was that same N2, and this angle was 75 degree. Now for this case, N2 is like this. Again this angle will be 75 degree. If this is 75 degree, then this will be N2 cos 75, and this will be N2 sin 75. So we have resolved the point 2 N2 force and N2 force. Now easily we can write down the equations of equilibrium. Let us write down summation Fx equal to 0. For block B, summation Fx equal to 0. That means I can write minus P plus 0.2 times of N3 plus N2 cos 75 plus 0.2 into N2 cos 15. Let us see whether it is correct or not. See, 0.2 N3 minus P plus 0.2 into cos 15 plus N2 cos 75 equal to 0. So if you solve this particular expression, you will get one relation in terms of N3 and P. So, but you can see you are getting 0.2 times of N3 minus P plus 0.193 times of N2. N2 already we have calculated, that is 1213.88 Newton. Substitute that value of N2 over here as well as over here also, 0.258 into N2, and then solve the entire expression. You will get one relation in terms of N3 and P. That is 0.2 times of N3 minus P is equal to minus 547.45, which is equation number 2. Any doubt? Any doubt in summation Fx equal to 0 for the wedge part?
No, sir, no.
Okay. Similarly, I can write summation Fy equal to 0. So if I write summation Fy equal to 0, that means I can write plus N3, this is your plus N3 minus 5000 Newton minus N2 sin 75 plus 0.2 N2 cos 15, sin 15 equal to 0. Okay, so just substitute the values. N2 already we know, so just substitute the values of Fy. So this is the equation N3 minus 500 plus 0.2 times of N2 sin 15 minus N2 sin 75 equal to 0. N2 already I know, that is how much, 1213.88 Newton. So just substitute the values of N2 in this particular expression, then we will get the value of N3, which is coming out to be 1609.48 Newton. And once you know the value of N3, substitute the value of N3 in the second equation, you will get the value of force P, and that force P is coming out to be 869.34 Newton. That means if you apply a force of 869.34 Newton, then this wedge will move along negative x-axis and this block A will raise along positive y-axis. So this is the complete solution of the problem. Any doubt?
No, sir, no doubt.
Others please respond.
No, sir.
Okay, okay.
No, sir.
Let us solve one more problem in order to gain the confidence. Let us solve one more problem related to this wedge friction. And this will be the last problem of this particular module. So read the problem. A block weighing 1000 Newton is to be raised against a surface inclined at 60 degree to the horizontal by means of a 15-degree wedge as shown in the figure. Find the horizontal force P which will just start the block to move if the coefficient of friction between all surfaces of contact to be 0.2. Assume wedge to be of negligible weight. Now in this question the wedge which they have used in order to lift this 1000 Newton load is your triangular wedge. Now due to application of this force P, wedge will move in this direction, then this block will be moving upward along this inclined plane. So what we need to find out? We need to find out what force P we should apply so that this particular motion takes place. Is it clear? The understanding part of the problem, or is there any doubt?
No, sir, no doubt.
No, sir.
Okay. Again the same concept. Individually we have to draw the free body diagram of wedge and the block separately, and we will write down the equations of equilibrium, and from those equations we will try to find out the value of force P. Okay. So let us firstly draw the FBD of the block. This is your block. This is my block. Okay. Weight of the block acting vertically downward, that is 1000 Newton. The block is in contact with this wedge, say at this surface. This surface is nothing but your second surface. So this wedge will give a reaction back to this block in this direction, that is nothing but your N2, so or R2, say R2, this is your R2. And since the wedge is moving along this direction, so at the point of contact the frictional force will act along this direction, which is mu into R. Sorry. I'm talking about the block. So for this block, since the block is moving upward, that means along this surface the block is moving in this direction, so frictional force will be in this direction, which is mu into R2. Then the block is in contact with this 60-degree inclined plane along this surface. Say that surface is nothing but point number 1. Then at this first point, a reaction force will be given by this inclined plane on this block in this direction. That is nothing but your R1. And since the block is moving upward, so at the point of contact I will get a frictional force in this direction, which is mu times of R1. So with this we have completed the FBD part of this block portion. Any doubt in this FBD part? कोई doubt है किसी
No,
को?
sir, no doubt.
No, sir.
Okay. So before writing down the equations of equilibrium, first let us resolve some forces which are not acting directly along x and y axis. Okay. So if I say this R2, this R2 is acting like this. This is your R2. If I consider this particular triangle, this is 15 degree, this is 90 degree, then this angle will be 180 minus 15 plus 90, which is 75 degree. That means this is your R2, and this angle is given as 75 degree. You can see. So this will be your R2 cos 75, this is your R2 sin 75. Now, since this block is moving in this direction and along the contacting surfaces it is moving in this direction, so at the contacting surfaces you will get a frictional force in this direction, which is mu into R2. See, mu into R2, and this angle is 15 degree. That means this is your mu into R2 and this angle is 15 degree. So I can go like this and like this. So this will be your point mu into R2 cos 15, and this will be mu into R2 sin 15. You can see over here. Similarly, if I talk about this particular surface, this inclined surface will give a normal reaction to this 1000 Newton block in this direction, which is nothing but your R1. Assume that this surface is nothing but my first surface, this inclined surface, this 60-degree inclined surface is nothing but my first surface. So R1, along this 60-degree inclined plane, the entire block is moving on in this direction. So you will get a frictional force in this direction, which is mu times of R1. Now let us resolve this mu times of R1. Now I can see that this angle is 60 degree and this is my mu R1. So that means this is mu R1 and this angle is 60 degree. So this will be mu R1 cos 60 and this will be mu R1 sin 60. See, mu R1 cos 60, mu R1 sin 60. So we have almost resolved the forces which were not directly acting along x and y axis. Is it clear, this resolving part, how I have did?
Yes, sir.
Okay. Electrical people, please respond whether it is clear or not.
Yes, sir.
Okay. Now I can easily write down the equations of equilibrium for this block A. So if I write summation fx equal to 0, what I can write? I can write plus mu r1 cos 60 minus mu r2 cos 15 plus r1 cos 30 minus r2 cos 75 equal to 0. Cos 30 is 0.866, cos 75 is minus 0.258 times of R2. Value of mu is 0.2 given in the problem. So 0.2 into cos 60 times of R1 minus 0.2 into 0.2 into cos 15 into R2. Okay, so if you solve this expression, that is summation fx equal to 0, you will get one relation in terms of R1 and R2, which is equation number 1. Any doubt in equation number 1?
No, sir, no doubt.
बाकी लोगों को कोई डाउट है किसी को?
No, sir.
Okay. Next, write summation Fy equal to 0. I can write minus 1000 Newton minus mu R1 sin 60 minus mu R2 sin 15 plus R1 sin 30 plus R2 sin 75 equal to 0. Again you substitute the values of mu, that is 0.2, in this expression and just solve it. If you solve it, you will again get one relation in terms of R1 and R2, that is 0.327 times of R1 plus 0.914 times of R2 equal to 1000. Now since both the two equations are linear equations, just solve these two equations, equation 1 and equation 2. You will get the value of R1 and R2. That is, R1 is 437.6 and R2 is 937.4. Is it okay?
Yes, sir.
Yes, sir.
Okay. Similarly, we have to draw the, similarly we have to resolve the forces acting on the wedge, those specifically those forces which are not along x and y direction. So I know that this R2 is how much? Angle 75 degree. For this particular block, R2 was acting like this. R2 was acting like this. But for this wedge, R2 will act in the opposite direction, but angle remains the same, that is 75 degree. So this will be R2 cos 75. This is R2 sin 75. Okay, then mu R2 is also acting. This angle is 15 degree given in the problem, that this is your mu R2, this angle is 50 degree, then this will be your mu R2 cos 15 and this will be your mu R2 sin 15. Okay, so we are done with the resolving part. Now let us write down the equations of equilibrium. That is summation Fx is equal to 0. That is summation Fx is equal to 0. So I can write plus mu R3 plus R2 cos 75 plus mu R2 cos 15 equal to 0. See, mu R3 minus P plus R2 cos 75 plus mu R2 cos 15 is equal to 0. Mu is 0.2, substitute, and you have the value of R2, that is 937.4 Newton, that also you substitute in this expression and just solve it. You will get one relation in terms of P and R3, that is equation number 3. 0.2 times of R3 plus 422.76 is equal to P. This is the third equation, which is summation Fx equal to 0. Similarly, I can go for summation Fy equal to 0 for for the same block, for that means for the wedge. So if I write summation Fy equal to 0, what I can write? Since the weight of the wedge is negligible, so I will not consider. I will write plus R3. I will write plus R3, then minus R2 sin 75 plus mu R2 sin 15 is equal to 0. Okay, so just substitute these values and just substitute the values of mu, which is 0.2, R2, and and then solve the entire expression. So you can see that the entire expression now reduces and takes the shape of only R3. So R3 is coming out to be 856.93 Newton. Now once you substitute this value of R3 in equation number 3, you can get the value of force P, and that force P is how much? 594.14 Newton. That means in order to raise this 1000 Newton block vertically, you have to apply a force of 594.14 Newton on this wedge. Is it clear? Any doubt so far?
No,
Hello.
sir, no doubt.
Okay, others please respond whether it is clear or not.
No, sir.
Okay, so these are some of the problems related to your wedge friction. You can practice some more problems from the book. With this, we have completed this module. I repeat, with this, we have completed this module. So I am ending my today's lecture over here. Fine. So please don't go anywhere. Just wait for a minute. Let me stop sharing my screen.